Alright, in this video we'll be looking at problems from page 493, 1 through 19 odd. This assignment is due April 16th. It's dealing with systems of equations. I'm going to do a couple of even problems that are similar to the odd ones that you'll be tasked with. I'm looking at problem number 4. Alright. It says we have y equals 1/2 x subtract 2 and 2x minus y is equal to -1. We need to graph these two equations. Well, this first one is in slope-intercept form. We can easily collect a couple points, x and y. We see this value is -2. That is the y-intercept, 0, -2. If you substitute 0 in place of x, 1/2 times 0 is 0. 0 minus 2 is -2. When x is 0, y is -2. We need any other point. I'm going to use 6. Substituting 6 in place of x, 1/2 of 6 is 3. 3 minus 2 is 1. When x is 6, y is 1. Alright. This equation, we could indeed solve for y. I'm going to use our x and y intercept method of finding a couple points. I'm going to substitute 0 for x and find the associated y. Substitute 0 for y, find the associated x. Substituting 0 in place of x. 2 times 0 is 0. Negative y equals 1. Dividing both sides by -1, we get y to be 1. When x is 0, y is 1. Substituting 0 in place of y, we're left with 2x. Coming above, we'll have 2x is equal to -1. Dividing both sides by 2, we get x is a -1/2. Alright. These are 2 points. We can now graph these and draw a line connecting them. Draw a line and find the point of intersection. Six 1 over 1, 2, 3, 4, 5, 6 up 1. 0, -2. 0, -2 would be here. Alright. Now we have 0, 1. 0, 1 would be here. -1/2 0. -1/2 0 would be here. Extending a line through these two. We see that we get this point of intersection. Right. If we had grid paper, we would be able to see the point a little more precisely, but it turns out that this point is -2, -3. -2, -3. This point satisfies both of these equations, and I will demonstrate that now. We have the equation y equals 1/2 x minus 2. Substituting -2 for x and -3 for y, y becoming -3 equals 1/2 times -2, subtract 2. Again, substituting -3 for y, substituting -2 for x. 1 times -2 is a -1. -1 minus -2, that's -3. And you see, indeed, -3 equals -3. This statement is true. Thus, this point does satisfy this equation. Now I'm going to show it substituted into this equation. We have 2x minus y is -1. Substituting -2 for x and -3 for y. 2 times -2 minus -3. Is that -1? Well, 2 times -2 is a -4. Minus a -3 is +3. -1 on this side. Negative 4 plus 1 is a negative 1, and indeed, negative 1 equals negative 1. That's true as well. So you see, this point, negative 2, negative 3, satisfies both equations. Thus, that point, negative 2 comma negative 3, is the solution to the system. Graphically, it's the point of intersection of two lines, and algebraically, it makes each of our statements true. All right, next we're going to move on down and look at one from it says addition method from the book. You will see that method also called the elimination method. All right, I'm looking at problem number 10. Number 10 is virtually identical to number 9 that you will have to do. This is like number 9. Number 10 has negative x subtract y is 4, and negative x plus 2y is negative 3. This one's actually slightly harder than number 10. I'm on number 9. On number 9, you can simply sum. Here, we're going to have to do a little multiplying. We're looking for additive inverses. That is two terms that will sum to 0. We almost have that here. We have negative x and negative x. If we multiply the entire top equation by a negative 1, multiplying by negative 1, we yield this new equation. X plus y equals negative 4. Notice all of the signs change because I multiplied by negative 1. Leaving the bottom equation the same. Negative x plus 2y equals negative 3. Now you can see we have our additive inverses here. When we add these two, they will eliminate each other. 1y and 2y is 3y. Negative 4 and negative 3 is a negative 7. Solving for y by dividing both sides by 3. We get that y is a negative 7 over 3. Alright, we will now take this fact that y is a negative 7 over 3 and substitute it in either equation. I'm going to go into this bottom one. So I have negative x plus 2 times negative 7/3 equals negative 3. I've substituted this value into the bottom one. Negative x, 2 times negative 7 will be a minus 14 over 3 is equal to negative 3. Adding 14/3 to both sides. Negative x will be 5/3. Dividing both sides by negative 1, we get x is a negative 5/3. And if you substitute these values for x and y, you'll see it satisfies both equations. Our solution is negative 5/3 comma negative 7 over 3. I'm going to look at the beginning of one of the problems that you have to do, and you can continue from there. I'm looking at problem number 13. All right. 13 gives you the system 2x minus 5y equals 16, and 4x minus 3y equals 11. Alright, what we're seeking is our additive inverses. That is, we want to have a positive and negative same absolute value situation. So here you see a 2x and a 4x. If we simply multiply this entire top equation by negative 2, we would have our additive inverses. I'll show that at this time. Multiplying the top equation by negative 2 times a negative 2. Leaving the bottom equation alone. Alright, 2x times negative 2 is a negative 4x. Negative 5 times negative 2 is a plus 10y. 16 times negative 2 is a negative 32. Multiplying all parts of it. This one we leave the same. 4x subtract 3y equals 11. Now we've obtained our additive inverses. This is what we're looking for. Negative 4x and positive 4x sum to 0. So in all of the subsequent problems, you're going to be looking to multiply one equation or both equations by some number to attain these additive inverses. Alright. You should be able to finish this one from here. A couple of additional notes. We had two special cases. We had one special case was the no solution case. No solution. Okay, and we had the no solutions when the lines were parallel. Lines parallel. Well, with regards to our elimination method, what's going to happen is we're going to do the eliminating, and we're going to end up with some statement like this: 4 equals 0. Alright? That is, the variables will fall out entirely, and we will be left with a false statement. Okay? So if you get this kind of situation here, you will state there is no solution to the system. Okay? The other special case, let me call this A instead of 1. Alright, the other special case, case B, is infinitely many solutions. Infinitely many. Okay? And we get that whenever the lines coincide. Lines coincide. Whenever you do your eliminating here, you're going to end up with some true statement. 4 equals 4, some true statement. In that case, you're going to know that there are infinitely many solutions. Alright? So these are the two special cases that you may run into with the rest of the assignment.